Земля борт.
Есть переход блока И на бортовое питание 30-й.
Есть отрыв.
Есть мачта 30-й.
Есть отрыв холодный пневмоколодок блока И 70-й.
Предварительно. Промежуточная. Главное. Подъем.
Двигатели центрального и боковых блоков вышли на режим главной ступени. 10 секунд. Параметры системы управления ракеты-носителя в норме. 20 секунд. Двигатели первой и второй ступеней работают нормально. 30 секунд. Параметры конструкции ракеты-носителя в норме. 40 секунд.
And they are off. The next batch of OneWeb satellites have started their journey on board Soyuz flight number ST-29, blazing a trail across the Siberian skies. We are looking there at the boosters, 4 of them burning, and they use a lot of firepower to get us away from the gravity of our planet. They're doing all the work right now. They burn for just under 2 minutes, and if we're lucky, we might even see them separating with the naked eye, because what we're looking at here is a nice, clean sky, clear sky, Maurizio. We're very lucky.
Very lucky tonight, and we're back.
Absolutely, Maurizio. We've lifted off. It's a long way to go, but you're back in action.
Back in action, absolutely. Our next 36 satellites, our batch 3 is on the way. And let's look what's going to happen over the next 4 hours. It's a bit of a long way to go, but looking forward to it.
And I think we are just seeing now the jettisoning of the boosters. Are we? We should see 4 dots.
130 секунд. Стабилизация изделия устойчивая.
Separating, we can see there it's going higher and higher into the sky, heading deeper and deeper into space.
Второй ступени работает нормально.
The next event is the separation of the fairing. Let's go back to you, Vincent. Have you got any news for us from your end?
Yes, so yes, we have the confirmation of the separation of the booster. Yes, so it is a good news. So we are getting the information from the team in the CVI. So the TV in French, so it means we control Israeli media. So this operation team is tracking the launch vehicle and receive the telemetry data from it, so they can consequently confirm major events when they have occurred, yes.
And it's incredible that we're still seeing these images here, even though we're now getting very close to the border with space. We're heading, or if not, we may have already got to the Kármán line. We call that the border with space. It's the point at which basically you have to use rocket science to stay up, because you can't use vehicles with wings anymore. And so we are getting close to separation of the fairing. Do you have any information yet on that, Vincent?
230 секунд. Параметры конструкции ракеты-носителя в норме. 240 секунд. Тангаж, рыскание, вращение в норме.
So we're still seeing those beautiful images there, quite remarkable. And we are scheduled to have lost our fairing, I think, by now, but we'll be waiting for Vincent to get those confirmations. And we're getting confirmation
So we
here
have-
that second
have
stage
confirmed-
is working. Nominally, we're burning the second stage right now because we've had the separations. So,
confirm the separation of the second stage and of the fairing, so ignition of the third stage as well. Yes.
в третьей ступени.
so OneWeb's going to give us fast internet from space. Let's take a little look now and see how the system is going to work.
Разделение второй ступени. Есть сброс панелей хвостового.
Since the beginning, the World Wide Web has never been worldwide. But OneWeb's new and truly global 5G-ready network will fix that. Say you're working on the edge of the world and need to do a video call. Perhaps you're mid-ocean or mid-air. Wherever you are, you'll have a signal. OneWeb will connect your device through a customized terminal that can be as small as a briefcase and just as compact. Whatever your location, the terminal encrypts your data and sends it at high speed to our satellite fleet passing overhead. These spacecraft are radically innovative, built in our own factory at 1/50th the traditional time and cost, shrunk to the size of a washing machine, yet engineered to deliver powerful throughput. Month by month, we're growing our satellite fleet, and soon we'll have not only the global spectrum rights, but the network reach to deliver truly worldwide coverage. And here's the revolutionary part. The fleet will be in low Earth orbit, 30 times closer to Earth than geostationary satellites. This gives you a stable, real-time connection with no interruption or annoying lag. What's more, our fleet always keeps moving, orbiting in a constellation design that creates seamless coverage. Each satellite uses a set of beams to cover an area the size of Alaska. Terrain is no obstacle. From its flight path and pattern, our fleet can always find your signal, so we can get you online from even the trickiest locations, with look angles that geo-satellite broadband simply can't deliver. We maintain high-grade system resilience from 2 ops centers using state-of-the-art ops concepts. Cloud architecture gives us powerful scalability and control remotely. For example, we can remove satellites at the end of their service life, so that the only trace we'll leave in space is on your screen right now. Now back to that video call of yours. We beam your data back down to Earth to our nearest satellite network portal. Then via one of our point of presence gateways, positioned in secure locations trusted by global providers, it re-enters the web. The journey you've just watched takes, at most, 1/10 of a second. And there they are. Your video call is good to start, whether with colleagues or your family back home. So you need never be out of signal or out of mind. OneWeb will connect you from unconnectable locations and keep you productive on the move. It'll be a breakthrough year when OneWeb technology creates real human progress, connecting everywhere, for everyone.
It's clever stuff, isn't it, Maurizio?
Very clever indeed, Katie.
Yeah.
And don't forget that, yes, it's exciting today, we're launching, but while we're launching, we have the factory in Florida with the OneWeb satellites. We're carrying on building and manufacturing our satellites, assembling them for the next batch. And don't also forget that we are deploying our ground network. So that is a fundamental piece, as you've seen from the video, of our capability to deliver global coverage.
So we're burning the third stage at the moment. Everything's going normally. Everything's going according to plan. So far, so good. Vincent, we're getting ready to switch the engine off, aren't we? Or Frigate's getting ready to switch it on?
Yes, Katie. We are getting to. Frigate is getting ready to switch on its main engine. So it is the first step called the pre-burn phase, so during 55 seconds. So it's giving a quick burst of acceleration, so to push the fluids back in the tank. So it is like when you accelerate in the car, when you get pinned back against the seat. So it is the first step of the Frigate mission. So this first ignition enables to inject the nose module to the intermediate transfer orbit. So it is an elliptical orbit, and the duration of this burn is just over 5 minutes. In the meantime, I can confirm that the third stage is separated, and it works. It has worked totally nominally, yes. And the first Frigate burn is as well confirmed.
So that's good. We've got confirmations there that everything's working normally. Everything's going according to plan. And just a quick description of what we're looking at here. You can see the third stage, the blue, obviously blue flame is the engine burning. Then the black disc and the silver disc are the third stage. Then we've got the gold structure, that's the frigate upper stage. And then we've got the satellites attached. And this is the scheduled moment now to switch off the upper stage engine. And we should see that then separating. There we go. It looks like that in space. These are CGI images which have been designed to show us what's happening up there in space. So now the next thing, as Vincent was just telling us about, Maurizio, is the ignition of the frigate upper stage. It's that gold structure there, and it's got all sorts of things on it. It's the brain of the whole vehicle. It's got the onboard computer. It can switch its engine on and off a number of different times while it's in space, and that of course makes it perfect for delivering all kinds of satellites to all kinds of orbits. And you could call it our celestial bus driver, and we're just waiting for it to switch its engine on right now. As Vincent was telling us, it's pushing the fluids back into the tanks. So it's just a little bit like if you put your foot on the accelerator of the car and you get pushed back against the seat of the car. That's what it looks like up there. Now, OneWeb are literally revolutionizing the way satellites are built. Let's take a look at how they do it.
The year was 1908, and the automobile was the prestige product of the age. Designed by brilliant engineers with names like Daimler and Benz, they were built one at a time by skilled craftsmen and sold in small numbers to the very wealthy. In that year of 1908, it all changed, because that was the year when the first Model T rolled off Henry Ford's assembly line. The car cost $23,000 of today's dollars, and the price fell every year until a decade later, Model Ts made up half of all cars in America. Ford conquered the market by making cars simpler and more standard, and by creating that famous assembly line to produce them in large numbers with consistent quality. Today, that same revolution is coming to a product that is literally out of this world. For decades, skilled engineers and technicians have been building satellites designed for unique missions and making them one at a time. They have delivered 1 or 2 dozen per year, each with a high price tag, and each designed to operate for decades in high orbit around Earth. But the business of space is changing as companies begin putting dozens or hundreds or thousands of satellites in orbit. Satellites whose cameras reveal Earth's secrets in astounding new detail. Satellites whose antennas bring high-capacity communication to the remotest corners of the globe. Space is nothing like the roads traveled by the Model T. It is airless, freezing cold and blazing hot, and flooded with radiation. Building for it is hard, but the assembly line has come to the manufacturing of satellites, and nothing will ever be the same again. In a new factory near Cape Canaveral, Florida, OneWeb Satellites operates the most automated assembly lines in the business. They run in a clean room the size of 24 basketball courts that keep them free of contaminants that could lead to failure in space. Components arrive at the building in a steady stream from a supply chain that stretches around the world. 2 weeks later, finished satellites emerge from the other side at a rate of up to 2 per day. In between is the assembly line, where engineers, technicians, tools, and robotics take part in a complex dance of creation. They build components into standard modules, and automated vehicles carry them to an assembly station, where teams assemble them into finished satellites. At each step, there are automated tests to check quality. Satellites that fail are sidelined for repair. And the testing isn't finished when the satellite is in one piece. It goes next into one of 32 special chambers for 2 days of testing to make sure it can survive the trauma of rocket launch and work reliably in the airless, blazing, and freezing conditions it will meet in space. Only when it has passed this battery of tests is it ready to be racked and stacked for its journey to the launch pad. Forecasters see an exciting future for space and satellite. Step by step, we are laying the foundations of a $1 trillion space economy, reaching from the Earth to the Moon and Mars. And with each step, life on Earth gets better. Fewer lives are lost to disaster, disease, and poverty. More food reaches the hungriest thanks to data from space. More people connect to broadband by satellite. And new industries begin putting the limitless resources of space to work for everyone. Rocket launches are thrilling, and rocket landings are a marvel. But it is on the humble assembly line that the future is taking shape every day. Space and satellite, the world's invisible, indispensable technologies. Brought to you by Space and Satellite Professionals International, with the support of OneWeb satellites. Additional support provided by AVL Technologies.
It's so exciting, isn't it? It's a new era in space. It's a new chapter. And of course, OneWeb's leading the way.
Yes, absolutely. And the analogy with the car manufacturing is spot on. And we're really changing, the paradigm of manufacturing satellites.
Yeah, really, quite literally, and changing how satellites are built and how people think about the manufacturing of satellites. So the Frigate upper stage is working normally. We know that we're burning the end of the Frigate upper and coming towards the end of the burn of the Frigate upper stage. And we're coming to the next phase, which is when it's going to switch off its engine, which will take us into really the next phase of the flight, as it were. So we will await for confirmation of that. But just to explain, ballistics, a ballistic phase, as we call it, actually means traveling without the engine. And we can see there, that's what it looks like. It's switched the scheduled time for it to switch its engine off. So we're coasting without the engine. But Vincent, this really, as I said, it's the next phase, isn't it, of the journey?
Yes, this is the next phase. So the Frigate engine works nominally, so it is a good confirmation. So we enter now a ballistic phase. So we are traveling high enough and fast enough to cruise without the engine. So during this phase, we optimize the orientation of the launch vehicle in order to ensure the best condition for Frigate, but also for the 36 satellites. So this ballistic phase is done with, I would say, a barbecue mode during 45 minutes. So that is to say, a rotation of the nose module around its longitudinal axis. So it is a ballistic phase with a duration of 57 minutes. And after this ballistic phase, there will be a second ignition of the Frigate main engine to circularize the orbit and inject the nose module into the satellite separation orbit.
I love the technical terms in space, the barbecue phase, which actually does what it says on the tin, because the upper stage, as you could see there, sometimes when you look at it, you actually see it rotating. So it is rotating as if on a spit. Of course, it's incredibly hot when you're facing the sun and incredibly cold when you're away from the sun. So you need to have that constant rotation just to keep the temperatures nice and even. We lifted off on the pad at 12:26. Today, that's 12:26 in London, and it was a really sensational launch, wasn't it? It was beautiful. Let's hope that we can have another look at it and replay that beautiful launch that we saw.
Промежуточная. Главное. Подъем.
Look at that. How did that feel when you saw that lift off, Maurizio?
It was a big relief, very exciting, Katie.
It's always good to get off the pad, isn't it? And we were actually incredibly lucky because we had very clear skies here at the Vostochny Cosmodrome. So it's obviously been a crisp day today. I can't see any clouds. We didn't go and tuck in behind the clouds.
We've been extremely lucky to be able to enjoy the launch in its entirety.
And the cameras actually followed the launch for what seemed like forever. That's very rare to get the luxury of that. We did actually see the boosters separating with our own naked eye or through the camera, although it was quite difficult to decipher them. But this is the sort of the halo effect, isn't it, of the engines burning, the 4 engines. Really quite spectacular. Vincent, you've seen lots of launches over the years. How did this one compare?
Yes, so it is yes, it is a fantastic event. You know, when you look at sort of launches from Peru and from Baikonur. So it is each time it is a new story which starts. Yes.
And of course, that was 20 or so minutes ago. But right now, our satellites are hurtling through space, riding bareback on board what remains of the launcher, the upper stage, attached to their special dispenser on board the Frigate upper stage. It looks like they're going quite slowly, but actually, we haven't talked about speeds yet, have we, Maurizio? But they're probably traveling around about 8 kilometers per second now, but they will have got up to about 9 kilometers per second. It's incredible. Can you describe what we're looking at here?
Yes, absolutely. So we are looking at our 36 satellites stacked on a dispenser, and here we actually can see how the satellites will look like after they separated from the frigate and the dispenser. We are looking at a trapezoidal pyramid with a truncated top. This is the way to optimize the accommodation inside the rocket fairing, so we can maximize the volume usage. After separation, the satellites will deploy